Hey everybody, it's Mr. Roy here. I want to give you a quick rundown for some info on section 3.2. I hope this will help out. Okay, so in this section we're going to be focused on looking at the standard form and the factored form, and I'm going to go through kind of what those two mean. You might have some idea about what that already looks like, but we're going to compare the two and then use them to try and solve some problems when it comes to quadratics. So just run through first a few quick reminders about some of the properties of our quadratics. So first one is that they have a x squared term. That's the biggest, that's the highest degree in the function, is that they're an x squared term. So that'll tip us off that something is a quadratic. Next one, we know that quadratics, they're functions, so they would pass the vertical line test, right? Meaning that we could draw a vertical line through it and would only hit the quadratic in one spot. We know they're kind of like a U-shaped curve when we graph them, like you can see on the right there. We know that their second differences are going to be pretty much constant. If something is a quadratic or close to a quadratic, the second differences will be close or quite close. Now, a couple of points here. The vertex, it's really important that we remember which part is the vertex. So when we're talking vertex, we're talking about this point right here, right at the bottom if it's opening upwards, or at the top if it's opening downwards. It's kind of where we change direction. That's what we're calling our vertex, right? So we can have coordinates for that on a graph. We would have coordinates of our vertex point. The term minimum and maximum value, some of you will know what this means, some of you may not know. A minimum or maximum value refers to our y value of our vertex. So let's say we're looking at the quadratic that's facing up. We're looking at this one right here. So the y coordinate of our vertex here would be our minimum value, meaning that's as low as you can go in the y in the y coordinates. That's the lowest one you can have. So we would say this quadratic has a minimum value. That's as low as you can go. This one, on the other hand, the dotted line one that's upside down, would have a maximum value because it's got a value that's as high as it can go. So we would have a maximum value for that one. So we can have a minimum and a maximum value. Depending on if it's facing up, we have a minimum. If it's facing down, opening down, we have a maximum value. And it's just the y coordinate of the vertex. Axis of symmetry is this dotted line we would draw that goes right through the center. So the axis of symmetry we describe by referencing what the x coordinate of the vertex is. So for example, this axis of symmetry, this dotted line that goes right through the vertex of this quadratic, we would say x equals, I don't know, I'm just going to make one up. Let's say 3. That happens to be where it is because that's the x coordinate of the vertex. So anywhere on that line, the x coordinates would be 3, and it kind of like makes a mirror that the quadratic is the same on each side. So we call that our axis of symmetry. Finally, for our x-intercepts. Now you remember a lot of this from 9th grade, x-intercepts. With a quadratic, we can have 0 x-intercepts, and I'll show you how that would look. Okay, so we could have a quadratic that doesn't cross our x-axis because it's above and opens upwards like this, or it's below and opens downwards like that. Either of those would have 0 x-intercepts. It never crosses the x-coordinate, the x-axis. We could have a quadratic that has 1 x-intercept. If it came down and just touched the vertex, oh, it didn't quite touch it there, just touches it right at the vertex, that would have 1 x-intercept. Probably the one you're most familiar with is a quadratic that have 2 x-intercepts, where it hits the x-axis twice, once and then twice. And for each of those, we could have a quadratic that opens up or down. So you can have 0 x-intercepts, 1 x-intercept, or 2 x-intercepts. All of those are possibilities. A little further, our y-intercept, when we're doing word problems, usually that'll be called the initial height. So if we're talking about anything that is something moving through the air with gravity, that's a quadratic, right? So kicking a football, throwing a rock, a satellite going around the Earth, anything moving in Earth's gravitational field will operate moving through gravity will be a quadratic. So if you read initial height in a question, usually that means your y-intercept. Okay, so we'll pay attention to that. Finally, we'll remember our step pattern if we're doing graphing for a quadratic. For a standard quadratic is 1, 3, 5. So we find our vertex and then we go over 1, up 1, over 1, up 3, over 1, up 5. And then we go back to our vertex and we go the other direction to the left, over 1, up 1, over 1, up 3, over 1, up 5, and that's how we could graph it. And finally, here are 3 forms of our equations. I know you probably know a lot of these already, but let's just go over these again so make sure we're really comfortable with them. So our first one, our vertex form, this is what we did in chapter 1, looks like this, right? And it's really easy for us to tell the vertex because all we have to do is take your h value and our k value, and that's going to be the coordinates of our vertex. So that's why we call it vertex form, right? Makes it really easy to find the vertex. Our factored form is going to look like we factored it, or we may have had to factor it ourselves, just like this. Now the x's are going to be x's when you do it, but the r and the s, those are going to be numbers, okay? And you might have a plus or you might have a minus in there. But you're going to have 2 brackets that are multiplying each other. You're going to have 2 things that are multiplying each other. And that's going to be our factored form. And we might have a number out in front, a coefficient out in front. We're just going to represent that with an a for now because we don't know what that would be. It would depend on the question. And it may just be 1, so it may not even appear there because we wouldn't write it if it was just 1. We've also got our standard form, and with our standard form, we write our x squared term first, our x term next, and our just regular number at the end. And the nice thing about the standard form is it makes it really easy to find our y-intercept because it's just going to be that c value right there. That's going to be our y-intercept. And I'll show you why a little later, but if you have it in standard form, y-intercept, really easy to find. There it is. It's whatever c is. So vertex form, easy to find the vertex. Factored form, now I didn't put this in, but it's really useful for finding the zeros, which means the x-intercepts, right? So really useful for that. And standard form, really easy for finding the y-intercept. So I'm just going to add in here x-int, because those are really good for finding the x-intercepts. Okay, so let's try out some actual questions, and let's see where we're at, see if we can try some of this out. So here's our first one. For each quadratic function, and we're just going to start with the one that's there. This one right here, here's our function. Determine the zeros, the equation of the axis of symmetry, and the coordinates of the vertex without using a graph. So the first thing I noticed about this is that this is in factored form because it's one thing in brackets multiplied by another thing in brackets. That's factored form. Right, so I'm going to say, okay, I'm just going to remind myself we're looking at this in factored form. Now, there's something really important that we can tell from this if we're working in factored form. Let's give ourselves a little axis here. In factored form, it's going to be really easy for us to find the zeros. So here's our quadratic. It's going to look something like that. And right here where it crosses the x-axis and right here where it crosses the x-axis, those are what we're going to call our zeros. Sometimes those are called roots. Sometimes those are called x-intercepts. Sometimes they're called zeros. So in your textbook, usually it's going to call them zeros. But just be aware, x-intercepts, roots, and zeros all mean the same thing. Okay, so let's see if we can figure out how this is going to work. So here's in my graph, I noticed that I'm hitting my x-axis. When I hit my x-axis, my y-coordinates are going to be 0, okay? Because if I go along my x-axis, anything that's on there is going to have a y-coordinate of 0. It's not up here, it's not down here, it's at y equals 0. So that means, really, I know that f of x, we used to write that just as a y, right, before we started getting into our function notation. So we really know that stands for the y value. So when the y value is 0, I know I'm going to have hit my zeros. right? So I'm going to substitute in a 0 for my y value. And when my y value is 0, I have to figure out what my x values are. If y is 0, I must be at the zeros. So let's figure out what my x values are. So here's what I'm going to do. I'm actually going to need to solve for x. I'm going to need to figure out what x could be. And there's actually a couple of options. So in order to get something that equals 0, I know I need to have either this thing be 0, and when you multiply them together, they end up being 0, or this one be 0, and when you multiply them together, you get 0. If either of these things in either of these brackets works out to be 0, then I know when I do my multiplying, the whole thing is going to work out to be 0. So basically what I want to do is I want to find my zeros by saying I'm going to figure out where this one is 0, what does x need to be? And for this one to be 0, what does x need to be? Okay, so I'm going to do that independently, and that's going to give me two different options. So let's start with this one. I'm going to draw a little arrow over here, and I'm going to say if this one is 0, we're going to have x minus 4 equals 0. That's one of our possibilities. Okay, now how do I solve for x? X isn't by itself. I need to get it all by itself. So in order to do that, I'm going to have to add 4 to both sides. Looks kind of like a 9. Just remember that's a 4. Not my best work. I'm going to add 4 to both sides, and I'm going to end up with x equals positive 4. So what this tells me is that one of my x-intercepts has an x value of 4 and a y value of 0. Because we know it has to be 0 when it has the x-intercept. So that's one of our x-intercepts. Let's do the same for the other one. So we've got 4x plus 5 equal to 0. Let's solve for x. First, let's subtract 5 from both sides. Now let's divide both sides by 4. Now that's going to equal negative 1.25, right? 5 over 4. Okay, so that means our other x-intercept is going to have an x value of negative 1.25 and a y value of 0. So those are my two x-intercepts. So I'm going to say here in green, I'm going to say those are my x-intercepts. One's going to be right there, one's going to be right there. So if I were to actually try and sketch this really quickly, I don't know exactly what it looks like, but I know that one of my x-intercepts is at negative 1.25. Let's say that's right here. And my other x-intercept is at 4, so that's like over here. So it's going to be something like that. Although I'm not really sure about all the details yet. So that's a good start. So we got our x-intercepts. Okay, let's do our next part. So we'll put a little dotted line here so we know we're moving on. What else do I need? I got my zeros. Now I need my equation of the axis of symmetry. So my axis of symmetry. Now I know my axis of symmetry is going to be right in the middle. It's actually going to be right in between those two zeros, those two x-intercepts. It's going to be right in between them. So to figure out where it is, I'm actually going to add them together and divide by 2. That's going to give me my axis of symmetry. So I'm going to say axis of symmetry. So my axis of symmetry, I'll take, it's going to be an x-coordinate. I'm going to take my 4, and I'm going to add it to my negative 1.25. That's going to end up being subtraction, of course, divided by 2. That's going to give me the average in between them. It's going to give me the spot in the middle. So that works out to 1.3 0.375. So that's my axis of symmetry. That means anywhere on this pink dotted line, that's going to be the x coordinate. I could have a high y value, I could have a low y value, I could have y value 0, but that's going to be the x coordinate the whole way along there. So that's my axis of symmetry. Cool, so I'm done that one. Let's draw a line through there. I just added them together, so divided by 2. Next, I want to find coordinates of the vertex. So I actually know one of them already, right? I know one of them already because it's going to be the same as the axis of symmetry. Because the axis of symmetry goes right through there. So I'm going to say, all right, my vertex I know the x coordinate is 1.375, but I don't know the y coordinate yet. So I'm just going to put a question mark in there because I'm not sure what that is. Now I can figure that out because I've got my equation. If I put 1.375 and I substitute that in for x everywhere, I see an x in the equation, and I solve it and figure out what it is, that's going to give me my corresponding y value. Anytime you put in an x value, and you plug it through your equation, what an equation does is it gives you the y value out the other end. So let's try plugging in 1.375 and see what I get for my y value. So I'll do that over here. So I'm going to say f at x, that's my y value, equals, now instead of x minus 4, I'm going to put in 1.375 minus 4. And instead of 4x plus 5, I'm going to put in 4 times 1.375 plus 5. So I've just substituted my x coordinate in anywhere I saw an x in my equation. Now, you can work that out. One little mistake I made here, just for correctness' sake. Instead of putting f at x, and congrats to anyone who noticed this, I should be putting in f at 1.375 because that really means I'm substituting that in for x. That's better. Okay, so 1.375 minus 4 looks like I'm going to end up with negative 2.625. And 4 times 1.375 plus 5 looks like I'm going to end up with 10.5. Okay, let's multiply those together. I had to stop and do that one on a calculator, and I'm going to end up with negative 27.565. So that's going to be the coordinate of my vertex. So let's just put a little therefore statement. We'll say therefore vertex is at, we'll do this in another color to keep it nice and organized, 1.375 and negative 27.5625. So that's the coordinates of this point right up here. Okay, so that wraps that one up. Let's move on to a new question. Here's one that says, express each equation in factored form, then determine the zeros, so our x-intercepts, the equation of the axis of symmetry, and the coordinates of the vertex. So the previous question we did, we had one that started out in factored form. This one does not start out in factored form, so we're going to need to take care of that. So let's first see what we can factor out. I noticed that I can take a 3, I can divide a 3 out of both of them, and I can divide at least an x out of both of them. I'm actually going to take out a negative 3x, just to keep this first term positive. So I divided out a 3, I'm left with just a 1. I divided out an x from x squared, I'm left with just x. And oh, that's going to be minus actually. Let's get rid of that. So I'm dividing this one by negative 3x. So 15 divided by 3 is 5. And the x divides out. Now you could check this just by multiplying negative 3x through, and you'd find you get the same thing that you started with. Okay, so now it's in factored form. Now these aren't in, this one's in brackets, this one's not in its own brackets, but it could be. It just so happens there aren't two terms in this part, but it's still one thing dividing or multiplying another thing. So we've got this in proper factored form now. This is actually a pretty easy one to factor because we didn't have to do any of our factoring tricks. We just had to pull out a common factor. So let's figure out what our x-intercepts, our zeros, are going to be. So this one I'm going to say, I'll go back to purple here. I'm going to go negative 3x when it equals 0. What is x? Well, let's start by dividing both sides by negative 3. So negative 3 divided by negative 3 is just 1, so we're left with just x. 0 divided by negative 3 is still 0. So that means one of our zeros is at the 0, 0 point, right? So we can actually write that in. We're going to say, okay, one of our vertices, or one of our x-intercepts is at 0, 0. When y equals 0, x equals 0. And I should put a 0 here as well, just to be correct. Now this one, how do we make this one equal to 0? So we'll say x minus 5 equals 0. Let's solve for x. Add 5 to both sides. We're going to have x equals positive 5. So that means our other x-intercept is at 5 and 0. So we say those are our x-intercepts. Right there and right there. And if we were to do a quick sketch, we'd say, okay, it's going to look like there's one at 0, 0, and there's one at 5, 0. So we'll put that over here. So something like that. I notice, though, I actually have a negative in front here. So that tells me I made a little mistake. This is actually going to be opening downwards. Because if we have a negative in the term in front, that actually means it's opening downwards. Okay, good. So we've gone from standard form. We've moved it into factored form. We found our x-intercepts, our zeros. So far, so good. Now we need to find our axis of symmetry. So again, that's going to be our dotted line that goes through the middle. And it's going to have an x coordinates that's the same as our vertex. It's going to be the point right in between these two. Now I can look at those two and say, oh, 0 and 5, what's halfway in between? It's 2.5. Let's actually go through the proper process to solve it. So we'll do this one in blue. So we'll say axis of symmetry. I'm going to write the short form this time so you can get used to that. AOS, axis of symmetry. So I'll say x is equal to the 2x coordinates added together of our zeros divided by 2. So x is going to be 2.5. So that means our axis of symmetry is going to be at x equals 2.5. No matter where you go, x is always 2.5. That's going to tell us a little bit about our vertex, right? But we don't actually know the final part about our vertex yet. It does tell us something, though. So we'll say, okay, looks like our vertex is going to be at 2.5 and something. How do we figure out the something? Well, let's put 2.5 into our equation, and that's going to tell us what the corresponding y value is. So we can pick either our original standard form, or we can pick our factored form. I think I want to pick the standard form because I think that would be a little bit easier. So I'm going to say f at 2.5 is going to be equal to negative 3 times 2.5 squared plus 15 times 2.5. So I'm not going to write that whole thing out. I think you can do that. Square 2.5, then multiply it by 3. That whole number is going to be negative. Add that negative number to 15 times 2.5, and we're going to end up with 18.75. So that's going to be our vertex. So we say, okay, our vertex is at 2.5 and 18.75. So let's actually draw what this looks like. Let's do a quick sketch. We kind of had it up here, but let's be a little more precise. So first I'll put on my zeros. One's at 0, 0. One's at 5. Right now it's opening down. And here's my vertex. And my vertex is at 2.5. That's halfway along in between the two. And 18.75. So this is 2.5 right here. And this is right here, 18.75. Okay, so we got all that stuff. We've done it both starting with factored form and starting with standard form and then having to factor. If we were given one that was even more complicated, we just say, okay, we just got to factor it first. Always start with factoring if it's not in factored form. Okay, next let's try one that's a little bit quicker, a little bit more straightforward. We're going to, I think I'm going to leave this one. To do this one would be the same, but you need to factor it first. So let me just briefly say, in order to factor it, you'd have to find something that two numbers that add together to -4 times 9, multiply together to be -4 times 9, which is multiply to be -36 and add to be -16. So just as a quick primer, you'd end up having to decompose this into plus 2x and minus 18x plus 9. So that's what you'd be decomposing that into. And then you'd have to factor it by grouping, and once you got it in factored form, then you could just follow the exact same steps. That's a bit on the long side though. I'm happy to do that during the tutorial this week if you want to see that. Or just let me know if you see a question like this in the practice quiz that you'd like me to go over. Though I want to go next to describe this. So express each quadratic function in standard form. Determine the y-intercept. Okay, so expressing in standard form, right now it's in factored form. To put it in standard form, I just need to multiply everything out. Something I need to be careful of though, there's this negative in front. Let's just put some brackets around everything and just leave that alone for now, and we'll deal with that negative later. And so I notice I'm going to be multiplying this 2x times this one and times this one, and I'm going to be multiplying the 1 times this one and times this one. So I gotta do my FOIL, right? First, outside, inside, last. Multiply everything in the first bracket by everything in the second bracket. So let's see what we end up with. We're going to keep that negative there. We're going to keep these big square brackets, and we'll say, okay, 2x times x is 2x squared. 2x times -1 is minus 2x. 1 times x is just x. And 1 times -1 is -1. Now we got to combine our like terms. I only have one set of x squared terms. I have minus 2x and plus 1. That's going to leave me with minus x and the minus 1. And now I got to deal with this negative. I actually need to multiply this negative, which is really a -1. Just don't write the 1. Got to multiply that by everything in the bracket. I got to multiply that the whole way through. Now you multiply something by -1, all it does is it changes the sign of the thing. So I end up with -2x squared plus x plus 1. So that's going to be my standard form. Now it's in standard form. The nice thing about standard form, which is really useful, is that you're able to look right here, right there. So that number at the end is going to be our y-intercept. This is because what is a y-intercept? Well, y-intercept is when the x value is 0, right? On the y-axis, my x's are 0. So that means anytime in standard form, I'm going to have a quadratic that might look something like that. There's my y-intercept right there. And so in my standard form, f of x equals ax squared plus bx plus c. This one is always going to be my y-intercept. Because if I plug in a 0 for x squared and a 0 for y, because that's where the y-intercept is, all of those are going to disappear, and all I'll be left with is this number on the end. So that's going to be my y-intercept right there. Oops. There we are. Okay, so I can say, great, that tells me I can say therefore the y-intercept is x coordinate is 0, y coordinate of 1. So that is our y-intercept. Those are the coordinates of it. Okay, so factored form, just multiply everything through. I end up with standard form. I just look at that number on the end. Because when I sub in a 0 for all the x's, that's all that will be left. That's going to be my y-intercept. Okay, let's do our last one here. Determine the maximum or minimum value for each quadratic function. Basically what that means is I got to find the y-coordinate of the vertex. But I also need to know if it's opening up or down, because that'll tell me if it is a maximum or minimum type of situation. So the first thing I notice is that when I multiply all this through, my x squared term, I'm not actually going to do it all, but if I multiplied 3x times x, I'd end up with 3x squared. So that is a positive number, and what that tells me is that I'm going to have a situation where my quadratic opens up, right? So the vertex is going to be right here. We're going to say it opens up. Here's my axis of symmetry, and my minimum is going to be right there. Okay, so I know now that it opens up. Good. Now let's go through the process of finding the zeros. So I'll say 0 is equal to 3x plus 14 and x plus 2. Let's take our first one. Moving kind of quick now because you've seen this before. 3x plus 14, I'll set that equal to 0. Solve for x. So 3x equals negative 14. X equals negative 14 over 3. And what does that work out to? Well, that's negative 4.6, and that keeps repeating. So I'll just put a line over the 6. How about my other one? Oh, this one's going to be nice and easy. X plus 2 equals 0. Well, that's going to be x equals negative 2. So those are my two x-intercepts. So I've got negative 4.6 repeating, and 0, and my other one is -2 and 0. I notice they're both on the negative side of the axis, so this one is shifted left pretty far. My axis of symmetry will tell me my x value for my vertex, so that's an important one. So, oh, I should mention that these are my x-intercepts, right there and right there. So my axis of symmetry, let's do that one. Axis of symmetry, boop, boop, boop. I find my axis of symmetry just by finding the average of the my two x-intercepts. So I'll say axis of symmetry, x is going to be equal to -4.6 plus -2. I'm adding them together. I'm dividing by 2. I end up with -3.3 repeating. So that's going to be my x-coordinate and my axis of symmetry. If I actually write down here, what's my vertex, right? I know it's going to be -3.3 repeating. Now this says I need my max or min, but I need my y-coordinate of a vertex. That's really the important part, right? And I don't know that yet. So I know that this one is my axis of symmetry right there, and this one is going to be my max min. In this case, it's going to be a minimum because I know it opens up. So that's going to be my max min, and I need to find that. So let's do that. Let's just close this part off. To do that, I'm going to take my function, and I'm going to sub in -3.3 repeating. So this is going to get a little messy, right? Because I'm going to have 3 times -3.3 repeating plus 14 times -3.3 repeating plus 2. I'm not going to go through all the steps for that. You'd have to work that out. Remember, proper order of operations. Do everything in the brackets first, then we're going to multiply what's in those two brackets. You should end up with -5.3 repeating. And plug that into our calculator. And we can say, oh, okay, cool. So I know that's going to be my max min value because that's my y-coordinate of my vertex. I know it's a minimum because that's the lowest it can go. And I'll say, therefore, the minimum is -5.3 repeating. That means that's as low as my graph can go. Okay, you've sat through almost 40 minutes. I hope this was helpful and has clarified some stuff for 3.2. Good luck. Send me messages if you want me to go through some other examples, say examples from the practice quiz or anything like that. Hope all's well. Take care, folks. See you soon.